Hi everyone, Brian Fraser here from Atoms and Systems. We hope you're enjoying the Blueprint tutorial video series, and if you have any questions, please contact blueprint@atomsandsystems.com. In part 2 of Hanging Virtual Arrays, you will learn the functions of the graphs available to you in the Cabinet tab. The Cabinet tab defaults to displaying two graphs at once. The bar between the two graphs can be moved to make either graph larger or smaller. The cross-section graph displays a side view of your PA as well as the area it is intended to cover. The bottom right-hand section of the graph displays the distance from the bottom of the array to the floor, the point at which the array begins coverage, represented by the green line in the graph, and the bottom of the array to the stage distance. We haven't added a stage yet, so this area is blank. Hovering your mouse over the display and using the cursor wheel will allow you to zoom in and out. Also, using either mouse button, you can drag the display left or right. Pressing the Reset button in the bottom left hand of the graph will reset it to the default view. The Autoshoot button brings up the Autoshoot function, which is a function we'll discuss in the next installment. The distribution graph shows box number on the x-axis and the distance between the focal point of each box number on the y-axis. The distribution factor is represented by the black line at the bottom, with a dot representing each box. The green line represents the desired distribution factor. This graph is important when using the Autoshoot function. The GM spectrum graph shows frequency response at a given point along the listening plane. The x-axis of the graph displays frequency, while the y-axis displays decibel level. The bottom left-hand corner of the graph allows you to change the guide mark, which is the point you are measuring the frequency response. Note that when you change the guide mark, the line in the cross-section graph shifts as well. The bottom of the graph allows you to change the scale in which you're viewing, and the coordinate box displays which point your mouse is hovering over the graph. When using the GM spectrum graph, as well as the SPL and vertical SPL graph, it's important to note which weighting you are using. Blueprint defaults to Y weighting at full range. Weighting options available are A, B, C, Y, and flat, which is no weighting. The A weighting curve is commonly used as a benchmark to determine overall loudness. The B weighting curve offers less attenuation in the lower frequencies, but it's rarely used. The C weighted curve offers much less attenuation on the upper and lower ends of the frequency spectrum. The Y weighting curve chiefly focuses on the spectrum between 2000 Hz and 8000 Hz. Adamson recommends using the Y weighting curve when designing your array. Because low frequency information is much less directional from line arrays, using any weighting other than Y is less desirable when designing your array. When changing the display within your array, the frequencies represented within the Y weighting curve will show the most level variance. The flat response is ideal when measuring the frequency response of subwoofer output. The SPL graph shows you an average frequency response across the listening plane. The distance of the SPL graph corresponds to the distance of the cross-section graph for easy comparison. The x-axis of the SPL graph displays distance, while the y-axis displays SPL level. When using the SPL and vertical SPL graphs, not only is weighting important, but you can choose specific frequencies. The frequency menus allow you to choose any standard third octave frequency, as well as full range, an average between 20 Hz and 20,000 Hz. A second frequency is available in the case that you would like to compare one frequency to another. The vertical SPL graph is the cross-section graph with the added capability of showing you vertical response across the listening plane. The x-axis displays distance, while the y-axis displays height. In the lower left-hand corner of the graph, a max SPL can be set. The resolution of the graph can be changed from normal to high-res. Changing the range allows you to determine the difference in decibel level between colors in the graph. When working with multiple arrays, checking the INT or interference box allows you to determine cancellation between sources. Clicking the button on the right-hand side of the graph brings up your color-coded scale. Pressing the Calculate button will begin calculating the vertical SPL. Pressing the Escape button cancels calculation. Please stay tuned for Hanging Virtual Arrays Part 3.